This is a video to show the amplitude surface for the Dakota seismic horizon that you have produced in the earlier assignments. You'll see here the color contour map corresponds to the Dakota seismic horizon. The times on the surface correspond to the two-way travel time down to the surface. So we can look and see, and it corresponds with the seismic data. What I would like to do is to prepare a map similar to this, except at each point on the surface, the map will show the amplitude of the seismic signal at the point where the surface crosses the seismic line. This can be helpful for determining amplitude brightness levels can indicate the presence of hydrocarbons or not. Now, this isn't a particularly exciting one in terms of hydrocarbon, but on the other hand, it is a tool that you will need to use. So the way I'm going to do this, determining amplitude is in a category called a surface attribute. Attribute just means a parameter of some sort that's measured at different places within the seismic data set. And the fact that it is a surface attribute means that it is applied just to the surface, in this case the Dakota seismic horizon. So I'm going to go down here. This is under geophysics in the pane to the lower left, and surface attributes is what we want. I've double clicked it, and this now allows me to select surface attributes. Now there are some things filled in here that I'm going to get rid of by clicking and hitting delete so that this looks like it would look if you first started. So I'm going to first of all place seismic data, because the inherent amplitudes are coming from the seismic data, the Teapot Dome data set. So I'm going to highlight that, and then I'm going to use the arrow to fill in the seismic data. I'm going to be adding information to the Dakota surface, so I'm going to select Add to Surface if it's not selected, and I'm going to go to the Dakota seismic horizon, select it, and I'm going to put that in here, and we'll see what that does in terms of adding a surface after we've created the surface. Finally, we go down to the horizon that for which we want to do the calculations. This also is the Dakota seismic horizon, so I will click here again, and it fills it in for me. Now, it turns out there are many kinds of surface attributes. The one we want here is about the simplest. It's called extract value. If it's not selected, click it here to select it. And it just means that wherever a point on the surface of the Dakota seismic horizon intersects the seismic line, it's going to tell us what the amplitude value is in the wiggles, in the traces of the seismic data. And because what I'm doing is we're not offsetting it or moving it around or averaging it over some time depth range, we're really just going to be selecting a single horizon. We're not combining different ones. We're not going to fiddle with any of these parameters. So we want above, we want none, search window 0, because we're just picking at the point where the surfaces intersect, and 0. So I'm going to come down here. None of these things need to be changed, and I'm going to click OK to actually create this surface. Now you'll notice that the seismic surface here changed to colors of blue and cyan instead. We can go over here, and this turns out this is the amplitude surface that we're working with. I'm going to come over here, and now under Dakota seismic horizon, we have another item. We have the two-way time. That's what we were looking at before. That's what you saw. And if I click this, this is now the extracted value. So it's the amplitude of the peak that you were using the tracking mechanism to pick the horizon. So I'm going to back out on this a little bit. And we can see that there are different values. Note up here, this color bar is the seismic value color bar. And that's because these amplitudes are actual seismic amplitudes. So we do see that there are some areas that are more cyan, meaning the amplitude is a little bigger. Where it's darker blue or gray, it's lower in amplitude. So we can, among other things here, see things like places where there are faults coming across in the gray and sometimes even red here, where the horizon hasn't picked very well, some very unusual looking features down here and up here in the northern part of that section. Now, in this case, this looks like some of the other surfaces we've used where they get funny colors, but this actually is a good choice of colors. If we were picking troughs, we would be getting reds and yellows to indicate the magnitude of the troughs. So this allows, if we go up to the 2D window, I'll select it. This one is now the Dakota Seismic Horizon, but I can also display that here. And now I have a map, and the dashed lines represent the inline and cross line that correspond to the 3D window that we're looking at. So this is a way to determine, to make an amplitude surface. It is a standard thing to do. You'll be doing it, I'm going to ask you to do it in the assignment here for Teapot and also for the 4 major surfaces that you'll encounter in the Boonsville data set. So key things, you must go down to the process down here, surface attributes, fill out the form, and then give it the correct input, and you will be able to obtain a surface for any of these, the second Wall Creek Seismic Horizon and Tensley. Thank you.